In June 2021, a video began racing across the internet. In it, an 11-story building seems to grow out of the ground in the Chinese city of Changsha, floor stacking on floor, until a finished residential tower stands where empty air had been. The caption attached to millions of these shares made a bold claim. China had 3D printed an entire building in just 28 hours. It was the kind of headline that spreads faster than anyone can check it. And it was wrong. No printer extruded that tower. No nozzle laid down concrete layer by layer to sculpt those walls. The truth is stranger, and in many ways more impressive than the myth. What you are watching in that viral clip is not printing at all. It is assembly. The building that rose in roughly 28 hours and 45 minutes was constructed by a company called Broad Group, and it was not created from raw material on the spot. It was built somewhere else entirely, weeks earlier, inside a factory. The rooms you see clicking into place arrived at the site already finished. Each module contained its own wiring threaded through the walls, its own plumbing, its own windows already glazed, its own floors and interior surfaces already installed. They were carried in on trucks, hoisted by cranes, and bolted together like the largest set of building blocks ever engineered. The 28 hours was real. The speed was real. But the magic word, printing, was a fiction bolted onto a genuine feat of manufacturing. This distinction matters, because the real method reveals how construction itself may be changing. To understand what happened in Changsha, you have to forget the image of a machine spraying a house into existence. You have to picture instead a production line, a fleet of trucks, a foundation poured long before the cameras arrived, and a choreography of cranes lifting steel boxes into a rising skeleton. Every part of that process has a name, a history, and a limit. And it all begins with the company behind the claim, a firm that had been chasing speed for decades before this tower ever left the factory floor. The company at the center of this story did not start in construction at all. Broad Group was founded in 1988 in Changsha by a former art teacher named Zhang Yue, and its first business was cooling. Broad made non-electric absorption chillers, industrial air conditioning systems that ran on natural gas or waste heat instead of grinding electric compressors. These machines cooled airports, factories, and skyscrapers across dozens of countries, and they built Zhang Yue a fortune and a reputation for engineering ambition. Zhang himself became a distinctive figure, an environmentalist obsessed with efficiency, energy waste, and the idea that the world builds things far too slowly and far too wastefully. That obsession pushed Broad toward a new frontier. If a chiller could be manufactured to precise tolerances on a factory line, Zhang reasoned, why not a building? Why should construction remain a muddy, slow, unpredictable process performed outdoors, one brick and one concrete pour at a time, when almost every other complex product, from cars to aircraft, is assembled indoors under controlled conditions? By around 2009, Broad had spun up a construction arm, later known as Broad Sustainable Building. Its philosophy was simple to state and hard to execute. Treat a building like an appliance. Manufacture the parts in a factory, ship them, and assemble them on site in days. Broad spent years proving the concept with escalating demonstrations. In 2010, it put up a 6-story pavilion in a day. In 2011, it built a 15-story hotel in 6 days. In 2012, the 30-story T30 hotel went up in about 15 days, its own viral video racking up views. In 2015 came the 57-story Mini Sky City, assembled in 19 days at a rate of 3 floors per day. Each project sharpened the same message: speed through prefabrication. Critics questioned quality, safety, and durability, and Broad answered with load tests, earthquake simulations, and standardized parts. By the time the Changsha Tower rose in 2021, this was not a stunt invented overnight. It was the product of more than a decade of refinement. To see how it works, you have to step off the street and walk onto the factory floor where the buildings actually begin. Inside a Broad factory, there is no scaffolding, no wet concrete, no crane swinging overhead. There is a production line, And along that line, buildings do not rise vertically. They roll forward horizontally, one module at a time, the way cars move down an assembly plant. Each module is a complete steel box, roughly the size of a shipping container but engineered to become a room. It begins as a welded steel frame, a rigid cage designed to carry loads and resist twisting. From there, the box moves station to station, and at every stop it gains more of a finished building. Workers install insulation inside the walls. Electricians run wiring and set junction boxes. Plumbers fit water pipes and drainage. Ventilation ducts are threaded through. Windows, already glazed, are mounted into their openings and sealed. Floors are laid. Interior wall surfaces are attached and finished. Light fixtures, switches, and outlets go in. By the time a module reaches the end of the line, it is not a raw shell. It is a room you could walk into and live in, lacking only its connection to neighboring modules and to the building's central systems. This is the core idea that the word printing completely erases. The building is not created on the construction site. It is created here, indoors, protected from rain, wind, and cold, where measurements can be held to millimeters, and where a worker never has to climb 11 stories to install a pipe. Quality can be inspected at eye level before anything is shipped. Materials stay dry. Work continues around the clock regardless of weather. The result is a strange inversion of normal construction. Traditionally, the messy, slow, labor-intensive work happens on the site itself, over many months. Broad's method pulls almost all of that work backward into the factory, where it happens in parallel, while the site is being prepared separately. The construction site becomes little more than a place of final assembly, but a room-sized steel box that can be trucked across the city and stacked 11 stories high demands more than careful wiring. It demands a very specific kind of engineering, built around a material and a structure. Broad calls its core. The heart of Broad's method is not concrete, but steel, and specifically stainless steel, arranged in a structure the company calls B-core. B-core is a sandwich panel. Two thin sheets of stainless steel enclose a core of small hollow tubes, or a corrugated pattern, all bonded together in a copper brazing furnace at high temperature. The result is a panel that is remarkably light for its strength, because most of its volume is empty space, yet extremely stiff because the geometry resists bending in every direction. It is the same principle that makes corrugated cardboard far stronger than a flat sheet, executed in metal. These panels form the floors and structural surfaces of each module. Stainless steel resists rust and corrosion, which matters when a building is expected to last for decades and to survive fire, moisture, and time. Broad claims its floors can carry heavy loads while weighing a fraction of a comparable concrete slab. That weight saving cascades through the entire design. Lighter floors mean lighter modules, and lighter modules mean less steel needed in the frame, smaller foundations, and loads that cranes and trucks can actually handle. Every kilogram removed upstream multiplies into savings everywhere else. Precision is the other advantage. Because the modules are manufactured in a factory using jigs and repeatable processes, each unit comes out nearly identical to the last, accurate to millimeters. In traditional construction, concrete is poured into forms on site, where temperature, humidity, and human error introduce variation. A wall might be slightly off vertical. A slab might cure unevenly. On a modular line, the same box is built the same way thousands of times, and deviations are caught by inspection before shipping. This precision is what makes stacking possible. When modules must bolt together across 11 stories and align their pipes, wires, and structural connections perfectly, there is no room for improvisation. The bolt holes must line up on the first try. Factory tolerances make that reliable, so Broad's tower is not stronger despite being prefabricated. It is stronger and more precise because it is prefabricated. But a finished steel room sitting in a factory in Changsha is useless until it reaches the building site. And getting it there introduces the single biggest constraint on the entire system: the road. A module can be as strong and as finished as engineers desire inside the factory, but it still has to travel. And the moment a room-sized steel box leaves the plant, it stops being a construction problem and becomes a transportation problem. Each module is loaded onto a flatbed truck, strapped down, and driven through the streets of Changsha to the assembly site. This journey, invisible in the viral videos, quietly dictates the shape of the entire building. Roads have widths. Lanes have limits. Bridges have height clearances and weight ratings. Highway overpasses hang at fixed heights, and traffic lights, power lines, and street signs all define an envelope the cargo cannot exceed. In most places, a load wider than roughly 3 to 3.5 meters, or taller than about 4 meters, requires special permits, police escorts, and careful route planning. Go bigger, and some roads simply become impassable. This is why modules are the size they are. They are not sized purely for comfortable rooms or ideal engineering. They are sized to fit legally and physically down a public road on the back of a truck. The transportation limit sets the maximum dimensions of every box, which in turn sets how the building is divided, how many modules it takes, and how they must fit together once they arrive. The truck, not the crane, is the hidden ruler measuring the whole project. Timing matters just as much. Delivering the modules for an 11-story tower means orchestrating a stream of trucks arriving in the correct sequence because the modules must be stacked in a specific order. The first-floor units cannot wait behind the 8th-floor units in traffic. Deliveries are scheduled so that each module reaches the crane roughly when it is needed, turning the road itself into part of the assembly line. This is also why Broad's factories and sites tend to be relatively close together. The farther a module must travel, the more the advantages of prefabrication erode into fuel, permits, and risk. Speed on-site depends on logistics off-site, and when those trucks finally roll up to Changsha, they arrive at a place that has already been quietly transformed, long before any crane lifted its first box. The video everyone shared began at hour 0, with the first module swinging into place. But hour 0 was a lie of omission. Long before the cameras rolled, before the first crane arrived in Changsha, another crew had already spent weeks preparing the ground. A building does not rise from nothing. It rises from concrete poured deep into the earth. In the days leading up to that June 2021 assembly, excavators cut into the site. Workers set steel reinforcement, framed footings, and poured a foundation designed to carry the weight of 11 stacked steel floors. Concrete does not obey the clock the way a crane does. It needs time to cure, days for the chemistry to harden into strength that can bear a tower. No time-lapse can compress that. The 28 hours you watched were the visible finale of a much longer process. Beneath the modules, engineers had already run the connections that make a building livable: water lines, drainage, electrical feeds, and the anchor points where each module would bolt down. These utility stubs weighted at precise coordinates, matched to the plumbing and wiring sealed inside every factory room. When a module dropped into position, its pipes met the site's pipes almost like plugging in a cartridge. That precision is only possible because the foundation was measured, leveled, and finished in advance. Get the base wrong by centimeters, and the entire stack of modules refuses to align. So the real timeline looked nothing like the viral clip. There were surveys, permits, ground preparation, and a curing foundation, all invisible, all essential. The 28 hours and 45 minutes measured only the assembly of the boxes, not the making of the site that received them. This is the first correction the footage demands. The building did not appear in a day. It was completed in a day, on top of work that had been quietly underway for weeks. With the foundation set and the utilities waiting, the site was finally ready for its spectacular moment. The trucks were loaded, the cranes were positioned, and the clock, the real 28-hour clock, was about to start ticking. The clock started, and the site transformed into something closer to a factory line than a construction pit. This was the centerpiece, the roughly 28 hours and 45 minutes that made Changsha famous. Cranes lifted the finished steel modules one by one, swinging each box from the staging area into position over the foundation. Every module already held its wiring, its pipes, its windows, its floors, and finished walls. Nothing was built here. Everything was joined here. That distinction is the entire story. Below each descending module, workers stood ready with bolts and connectors. As a box settled onto the level beneath it, they locked the steel frames together, securing the structural spine of the tower. Then came the services. Water lines met water lines. Electrical runs met electrical runs. Because each connection point had been engineered to the millimeter in the factory, the site work became assembly rather than fabrication. The choreography moved floor by floor. A ring of modules formed the first story, then cranes stacked the next ring on top, then the next, climbing toward 11 stories. Spotters guided each lift by radio and hand signal. Riggers hooked and unhooked. Bolt crews followed close behind, sealing joints as the tower grew taller by the hour. There was no drying concrete to wait on, no scaffolding raised over weeks, no interior fit-out to begin after the shell was done. The interiors had arrived already finished. That is why the footage feels impossible. Traditional construction spreads these tasks across months and dozens of sequential trades. Modular construction ran them in parallel inside a factory, then compressed the final union into a single continuous shift. The building climbed while most cities were still asleep, floor stacking on floor, box locking to box. When the last module settled and the final bolts tightened, an 11-story residential tower stood where hours earlier there had been only a foundation. It was extraordinary, and it was real. But speed like this comes with a price the viral clip never shows. For all its precision, this method runs into hard walls, limits that keep it from replacing conventional building everywhere. So why isn't every city stacking towers in a weekend? Because modular speed collides with limits it cannot engineer away. The first is transportation. As we saw on the road to Changsha, every module must fit on a truck and travel public roads. Lane widths, bridge heights, and turning radii cap how large any single box can be. You cannot factory build a room wider than the highway that carries it. That physical ceiling shapes the entire design before an architect draws a line. The second limit is the foundation. No matter how fast the boxes stack, concrete still needs weeks to cure. The dramatic 28 hours sits on top of a slow, unglamorous timeline that cannot be rushed. Assembly is fast, preparation is not. Then there is regulation. Building codes were written for conventional construction, inspected trade by trade, layer by layer. A finished module arrives, sealed, its wiring and plumbing hidden behind walls, poured in a distant factory. Inspectors cannot easily verify what they cannot see, so approval systems must adapt, and in many countries they simply have not. Permitting, zoning, and certification often take far longer than the build itself. Design flexibility is another wall. Modular systems reward repetition. Identical boxes, identical connections, identical rooms. That efficiency works beautifully for apartments, dormitories, and hotels, where units repeat by the hundred. It struggles with the irregular, the custom, the one-of-a-kind. A signature museum or a sprawling curved facade resists being sliced into shippable rectangles. Finally, there is scale and logistics. A factory must exist near the site, or transport costs erase the savings. You need cranes, staging areas, and a supply chain of finished modules delivered in exact sequence. Miss one box and the stack stalls. These constraints explain why the Changsha Tower remains remarkable rather than routine. Broad Group did not defeat construction's fundamental problems. It relocated most of the work into a factory and left only the assembly on site. That is powerful, but it is not universal. Understanding these limits is the key to understanding what the 28-hour tower actually proved and what it did not. Strip away the viral captions and the myth of the printer, and what remains is something quieter, but more profound. The Changsha Tower was not conjured. It was not extruded from a giant nozzle. It was manufactured, the way cars and appliances are manufactured, then delivered and assembled on site. That reframing changes everything. The genius of Broad Group was not inventing a magic machine. It was applying the logic of the assembly line to the oldest industry on Earth. For centuries, buildings were made in place, weather exposed, trade by sequential trade, each step waiting on the last. Broad asked a different question. What if the building came to the site already built, in pieces, like a product rolling off a factory floor? Inside that factory, steel modules were welded with precision no muddy construction site could match. Wiring, plumbing, windows, and finished interiors were installed under controlled conditions, tested and sealed. The 28 hours and 45 minutes we celebrate were simply the moment those finished products clicked together over a foundation prepared weeks earlier. The speed was real, but the speed was a symptom, not the achievement. The true achievement was moving construction indoors, turning a chaotic craft into a repeatable manufacturing process. That is why the limits matter. Transportation caps the boxes. Codes lag behind the method. Foundations still cure at the pace of chemistry. Custom shapes resist the assembly line. These are not failures of the idea. They are the honest boundaries of what manufacturing can and cannot yet do for buildings. So when you watch that tower rise in fast motion, resist the easy story. Nothing was printed. Nothing appeared from nothing. What you saw was the final scene of a long industrial process, revealed in a single spectacular shift. The extraordinary part is not the illusion. It is the reality. An 11-story building, produced like a machine, shipped like cargo, and locked together like parts. That is the correction this film exists to make, and the thesis to carry forward. The 28-hour Tower of Changsha was built in a factory, not printed.